is Mrs. T. I'm having trouble with my webcam, so you've just got my voice today. Nobody needs to see me for this anyway, but we are going to talk about topics from Chapter 14. Chapter 14 talks about several different concepts having to do with theories, widely accepted theories about how and why the Earth rumbles with earthquakes and why we see such similarities in the fossil record from one continent to the next, and some of the seafloor spreading concepts that we've looked at in a previous lecture. Anyway, so this set of lessons covers some theories about all of this continental drift and plate tectonics. So, the first thing I want to do is talk about what a theory is. You hear about theories all the time in history class or sociology class or now geography or biology, or all these different sciences and social sciences have commonly accepted sets of explanations for things that scientists commonly agree on are probably a viable explanation for why something happens the way that it happens. And so that's what a theory is. It's just a set of explanations that scientists commonly accept because it makes sense. And there's also usually evidence to support these theories. Over time, there's a whole lot of empirical evidence, data that we can gather and examine that supports a theory or it rejects a theory. And so that's what essentially a theory is. So in chapter 14, we're going to look at two primary theories that refer to or explain, attempt to explain the internal processes of the Earth, some of which we looked at in chapter 13. Okay, so the first one we want to talk about is continental drift. And I've got, yes, here's a map or a before and after of what continental drift essentially is. This map that I was on a minute ago, where is it? There we go. This map that we started on, these red borders on this map are the outlines of tectonic plates. And this map that I have over here, this comparison map, shows you a timeline, a before and after essentially. When we're looking at this before picture, it has the word Pangea here. That is a name that is agreed upon in science for a supercontinent that existed about 300 million years ago, based on the fossil record. And based on the concept of continental drift, which has only really been accepted in our field or in science in general for about the last 100 years, 120 years, something like that, that continental drift has been talked about and examined and data gathered about it to try to prove or disprove it. But this concept of continental drift is the commonly accepted idea that the land masses that exist on the Earth were once all connected. So the way this map shows you the landmass of Pangea, the lighter colored kind of golden spots on this landmass would be above water, and these darker spots would be down at sea level or filled with water, like as in lakes or rivers, for instance. And this, of course, is a hypothetical. We don't really know exactly what it looked like, but you can see on this solid continent that we have modern names for countries and for continents that we know of today. So South America and North America are continents. If you look carefully here, where I have the arrow pointing, this little patch up here resembles the island Greenland. You have Eurasia here, which of course is a combination of what we know of now as China and Russia and Europe. Here would be some of the Middle East, or the Near East, even the Mediterranean Sea would be about right here. Anyway, here's India. What scientists propose was Australia, Antarctica, all connected at one point. And then over the last 300 million years, you have changes. Let me see, I think I have Oh, I have a better picture, I think. Let me see, is it down here? Well, over the 300 million years, you go from, here we go, from one solid landmass to some breaks in the plates on the Earth, and you have about 90 million years ago, a section of the Pangea original continent known as Laurasia, and the southern part here, Gondwana, that's the name that science agrees on, is most likely uh, what resulted in a split here before the actual continents drifted away. And you can see again in this representation roughly the shape that we know of North America, has today, roughly the shape that South America has today, Africa, etc. And the reason that we in science agree on this, there was a German scientist who gave us this concept. Alfred Wegener is his name. But the reason we agree on this is because we can look at the fossil record. For instance, this graphic that you see on the screen now, we can look at the fossil record and find certain animals and certain plants that have been preserved over these millions of years, and the swath of area where they have been preserved can travel across, well, in this case, 5 continents. India is part of the continent of Asia, and so we have, for instance, this Glossopteris that you can find fossil evidence of that plant being in what is now today South America, being in a swath of Africa, as you see this belt going across here, being in a part of Asia, this southern tip of India, being part of Antarctica even, and Australia. And so there's a lot of biome information that we use to understand continental drift, and there's a lot of plate tectonic information that we use to understand continental drift. Let me go back to my other map. I've lost it. There we go. Okay, and so these red lines here represent the different plates, the tectonic plates that exist in the world today, that we've identified and exist in the world today. And so if we look at this area where I'm pointing at here, what we know of as California and the Baja Peninsula of Mexico, on the North American plate, the North American plate is the terrestrial plate where our feet are right now. At least I assume you're in the United States with me. But you can see how close you might know or have heard of in your lifetime or seen sensationalistic movies like San Andreas, which is completely unrealistic, but you might have seen or heard about California being prime real estate for earthquakes, and that's because of this plate boundary here, where you have the North American plate and the Juan de Fuca plate meeting, and it's the way that they meet and the earthquakes that happen along there. We won't go into at the moment the kind of fault line that exists there, but it's the kind of fault line that makes a movie like San Andreas completely and totally unrealistic and cartoonish. So, but it sure was fun to watch that movie in the cinema, but it's completely unrealistic. But you do have a lot of activity, seismic activity, out here in California. One of my favorite websites to use is earthquaketrack.com, and I opened it up today to look at it. You usually see a whole bunch of earthquakes in California, but today there happened to, or yesterday that is, there happened to be an almost 5 magnitude earthquake in Texas, of all places, in the United States. But this area here on this map, where you see San Francisco and Sacramento, Los Angeles, San Diego, these cities are right on the edge, the boundary of the Juan de Fuca plate and the North American plate. And then we have the Cocos plate down here, close to the Baja Peninsula of Mexico, or underneath the Baja Peninsula of Mexico. So these plate boundaries and the internal combustion, if you will, the internal convection that happens within the Earth that we learned about in the last unit, this constant motion, this constant pressure, and the seafloor spreading, and volcanism, and plate tectonics, all of these different observable phenomenon that we can find in the Earth is why, and this image that I've just scrolled up a little bit so you can see this image, gives you kind of a graphic representation of the lithosphere here, that the upper part of the mantle, the hard part of the mantle, and the crust. And it's in the crust of the Earth where these plates exist. And so we know that below the crust of the Earth, you have molten layers, liquid layers of the Earth. And so the theory is that these plates are simply floating and crashing into each other and pulling away from each other and slipping against each other. And the veins of lava that come up in a volcanic ridge, for instance, are exhaust, so to speak, from this lava underneath these plates. But it's from all of these internal processes that the original Pangea continent, back to my original continental drift picture here, the original Pangea continent broke apart, floated away from itself. And you will read in the textbook and in one of the curated videos that you're going to watch, one of the narrators refers to the jigsaw puzzle type fit that modern continents seem to have with each other. And this graphic sort of shows that that phenomenon, with Australia probably breaking off of Antarctica here, and India fitting pretty well right there, and even the Middle East down here, and South America from Africa, etc. These patterns are relatively obvious when you look at the topography and the land masses that certain places share in common, and certainly this fossil record, when you look back to see what kind of bones from animals, what kinds of plant life fossils are in common from these different areas, it also helps decide where the puzzle pieces fit. And so this chapter is about those phenomenon. There is a concept called the ring of fire that I'm going to point you to in another, well, it's in the reading assignment that we have for this lesson, but I'm going to point you or curate a video for you about the ring of fire, because it'll tell you how sometimes land masses that exist today have been created well after this continental drift through volcanism. You can have a volcano on the bottom of the ocean, or at the boundaries of some of these plates. And in the case of the ring of fire, it's at the boundary of plates where you constantly have molten lava creeping up, and it breaks through the water, and it becomes a landmass over many, many, many hundreds of thousands of years. And it degrades, and there's internal soil processes, and plant life accumulates there and begins to live there, and animals migrate there, etc. And it becomes a biome in and of itself. And so we will be looking at some of that in the curated videos. But for now, this is what I would like to talk to you about regarding chapter 14, and I hope that you will text me with questions and let me know how everything is going. I will be grading unit assignments and posting those grades, so be sure and watch for that, and I will see you in the next one. Hopefully my webcam will be working, and I'll see you in the next one. Bye.